Welcome. We're going to go over the video for the study guide to help you prepare for the test. Question number 1 says, what is the domain and range of y equals the absolute value of x plus 5 plus 4? So what I did is I went and graphed it. This tells me that it moves at left 5 because it's in parentheses, it's a liar, and it's up 4. So my domain is all real numbers. All real numbers. And in interval notation, that would just be negative infinity, comma, positive infinity. My range is the lowest number on the graph, 1, 2, 3, 4. So y is greater than or equal to 4. In interval notation, it's touching, so I use the bracket. 4, and it goes up to infinity, so that's the parenthesis. It looks like that. For question number 2, what are the x and y intercepts? To find the x-intercepts, I plug in 0 for y and solve. 0 equals x squared plus 9. I'm trying to get the x by itself, so I'm going to move the 9 to the other side. And now the 2 is squaring, so the opposite of squaring is the square root. And the square root of 9 is 3 times 3 and negative 3 times negative 3, so plus or minus 3. So this is going to cross the x-axis at plus and minus 3. To find the y-intercept, I plug in 0 for x. 0 squared is 0. 0 minus 9 is negative 9. So the y-intercept is at negative 9. All right, this would be a really good question to know how to do on the test. Identify the domain and range. The domain is all real numbers because it goes to the left forever and to the right forever. And the range, the lowest number is negative 9, and it's touching negative 9, so that's a bracket negative 9, and it goes up towards positive infinity forever. So that's my domain and range. My x-intercept is right here and right here, so that is negative 4 and 2. My y-intercept is right here, and that appears to be at negative 8. So the y-intercept is at negative 8. On what intervals is the function positive? Positive simply means above the x-axis. So it's positive starting all the way over at negative infinity. It's positive at positive, and it stops right here at negative 4. It's negative, 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 and then it starts being positive over here at 2 and continues on until infinity being positive. Where is it negative? It's negative from negative 4. So it's negative, 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 all the way over here till 2. So that's where it's negative. Where is it increasing? Well, we're decreasing, 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 stop, and then it starts increasing, and this is actually at negative 1. So it's increasing at negative 1 to infinity. Where is it decreasing? Well, it started at negative infinity. It's always decreasing until it gets to right here, and that is at negative 1. And it's not increasing or decreasing, so that's why we use a parenthesis. It's not actually touching. What is the average rate of change from negative 3 to 2? That's an interval. So we need this coordinate right here, 1, 2, 3. And I go down 1, 2, 3, 4, 5. So negative 3, 5 is my first coordinate, and then 2, 0 is my second coordinate. x1, y1. x2, y2. y2 minus y1 over x2 minus x1. It's our slope formula. It should be familiar to you. y2 is 0 minus 5 over 2 minus negative 3. 0 minus 5. One second, let me make sure that's right. Negative 3, that should be negative 5. I apologize for that. So that makes that negative. 2 negatives equal positive, so 5 over 5. 5 over 5 reduces down to 1. All right, x squared plus 3, this is our k value. Our k value is not a liar. So what I'm looking for is which graph has been raised 3, and that would be D. This one is also the k value. The k value is not a liar. Which graph has gone down 3? So that would be A. This is in parentheses, so it controls left or right. It is a liar. So actually this one is 3 to the left. This one is 3 to the left. This is a liar. It's not, even though it's x minus 3, it's really 3 to the right. So that one would be B. All right, let's keep going. Graph the function of the parent function. Y equals 3 times the absolute value of x. Well, since I know this is an absolute value, what I'm going to do is go 2 numbers to the left, 0 and 2 numbers to my right. So 3 times the absolute value of negative 2. The absolute value of negative 2 is positive 2. 3 times 2 is 6. 3 times the absolute value of negative 1. The absolute value of negative 1 is 1. 3 times 1 is 3. 3 times the absolute value of 0. The absolute value of 0 is 0. 3 times 0 is 0. 3 times the absolute value of 1. The 1 is positive. 1 times 3 is 3. 3 times the absolute value of 2 is 6. So now I'm just going to plot these points. Back 2, up 6. Back 1, up 3. 0, 0. Over 1, up 3. Over 2, up 6. Draw my lines, and we just stretch that graph. All right, let's move on. Derek walks to his best friend's house at a rate of 1 block per minute, then turns around and walks home. The graph shows the distance Derek walks in the given amount of time. Write an equation. Well, our equation is at y equals a x minus h plus k. HK is my vertex, so this is my h, this is my k, and this occurs at 10, 10. I need another point. The easiest point to use would be 0, 0. So that's my x, that's my y. So now I'm just going to plug in. 0 equals a x minus 10 plus 10. 0 minus 10 is negative 10 plus 10. The absolute value of negative 10 is plus 10. 10 times a is just 10a. Minus 10 minus 10. Negative 10 equals 10a. Divide by 10, divide by 10. Negative 1 equals a. And on this problem, my final answer needs to be in this form. Y equals negative 1. Absolute value of x minus h. Remember my h was 10. Plus k. My k was 10. Plus 10. That's my final answer. All right, let's go on and look at the next one. These are graphing. So this one I'm going to have an interval or a boundary at negative 2. So I'm going to go back 2 and draw my boundary. I'm also going to have one at positive 2. All right, from there, I'm going to make my little function table. All right, so what's going on here is, all right, when x is less than or equal to negative 2, my y value is negative 4. So I'm going to go back 2, down 4, 1, 2, 3, 4. This is a closed circle. Remember, less than or greater than is an open circle. Less than or equal to or greater than or equal to is a closed circle. All right, next. So this is going this way. All right, here we go. Let's make a function table for this. This is my y coordinates. Just a second, please. All right, so I'm going to use -2 and +2. -2 minus 2 is -4. And my other coordinate is 2 minus 2 is 0. Back to down 4, 1, 2, 3, 4. Unfortunately, this is under the same exact circle, so you're not going to be able to tell it's an open circle, but it is. So now I'm going to go over 2, up 0, and this is an open circle as well. And I just connect my two circles. All right, for the one down here. So just to add a little color, I like one of my students did this today and it made a lot of sense to me. So we will try this as well. This was my top line right here. So that's this right here. This line right here is right here, which is this line right here. And then we have one more line to do. Let's see here, which is going to be this one here. So I'm going to do x, -2x plus 4. We're going to go 2. -2 times 2 plus 4. -2 times 2 is -4. -4 plus 4 is 0. I want to do one more line greater than 2, so I'm going to do, we can do 4. -2 times 4 plus 4. -2 times 4 is -8. -8 plus 4 is -4. All right, let's graph this point. Over 2, up 0. This one is a solid line, so I have to color that one in. Like I said, it's on top of it. I know it's a little weird, but it's fine. Now I'm going to go over 4 and down 4. That's just a point on my line. It's not my actual, it's not a circle. We only have circles where our line starts and ends. And then I'm going to draw that, and we are done. Oops, I kind of missed. Let's fix that. All right, the next line. Let's go ahead and graph this. Now, this is where I'm going to have my boundaries at -3 to 1. That's my first set of boundaries. From 1 to 4, 4 to 6, and at 10. So that's where all my groups of boundaries are. So what I'm going to do here is I'm going to go back 3, up 2, and this is a closed circle. I'm going to go over 1, up 2, and this is an open circle. And now I'm just going to connect them. Then I'm going to go on to the next one. I'm going to go over 1, up 5. This is a closed circle. I'm going to go over 4, up 5. This is an open circle. Ooh, I didn't do a very good job on that one. There we go. I fixed it. I'm going to go over 4, up 8. This is a closed circle. I'm going to go over 6, up 8. This is an open circle. And now let's do the last one. Over 6, up 10. This is a closed circle. Over 10, I think I misspoke. I was supposed to go over 6, up 9. I went too high. I'm sorry about that. I'm just going to change that to a 10. Over 10, up 10. And this is going to be an open circle because that's a less than. That's how you do this section here. Last part here, this is my x value and it wants to know what my y value is. So I go back 1, it's hitting the line right there, so that happened at 0. I'm going to go over 2, where is it hitting my graph? At 1. I'm going to go over 1, it's hitting at 1. I'm going to go back 2. Now remember, if an open circle is not touching, so that's not our answer. Our answer is right here at -1, over 0, and 1. Hopefully that helps you. I'll see you in class.